session with me. So it's a very pragmatic and practical session. Do you have your laptops? Just kidding. So today I'm going to be talking about pragmatic data organization leadership. So my title says Director of Data Platform, and when I submitted the call for papers, I was still leading about 3 data teams, but now leading an organization of 70 people. I have one of my colleagues here, and she already asked me, why didn't you change the title? But it was because I submitted the talk a while back. But this is going to be a very pragmatic session. Just let's walk through what it looks like. Usually this is a workshop, right? This is about 6 line items on the agenda, but I try to condense it as much as possible into 3 sections. So the first part, we're going to look at how to organize teams, customer view first, and I think the previous speaker, Marty, already spoke about having the customer view. And then we're going to dive deep into the ways of working. Finally, the Q&A section, we don't have to do it here. You do it at the speaker office hours. But it's going to be very pragmatic. I would say, yeah, and if you have any questions, please feel free to, let's catch up together. All right, the team structure. Usually this is, when I was an engineer, I was usually very baffled at the fact that when product people and sales people talk to me about customer view first, I was always wondering, why not take the technology view first? But then I got to realize that over time, we're trying to use technology to serve the customer through the business. And this is what this looks like. For data teams, right, I think for most software teams, it's usually we have the organization and then we're delivering value to the customer. But then this is not where the organization ends. The organization also continues from the customer into how we make money, right? And data teams have to realize that there is the organization, we're delivering value to the customer or the user, depending on your business model. And there's also data being involved in how the company earns money. And question to the audience, how many of us actually know how our companies earn money? Good. Get more involved, please. Even when you're software teams, or even as engineers and engineering leaders, please get involved to know how the company actually makes money. Not how we ship features to the customer, but how the company actually earns money. Because this is one of the things that I do with my teams, right, the data teams, which is, yeah, you're building this amazing cool feature, you're doing AI, machine learning, building a data platform, but do you actually know how the company makes money? This is why in my onboarding sessions for the new team members, they spend the first week learning about how the business works. And for them, it's kind of counterintuitive because they want to get into the code. I want to write some Git messages, Git push to some master branch or some main branch, depending on how you want to term it. But for me, it's very important that data teams, and including software teams or technology leaders, we need to understand how the company makes money. The reason for this is that there is a need for data expertise beyond shipping feature to the customer. Because if you think about product teams, the way we're organizing around to customer or to user. But then if you then think about how data teams can enable other functions in the business, think about compliance, think about finance, think about legal. These are areas where data people or data experts can have significant impact. You can imagine how if you're procuring a new software and you have to go through the non-disclosure agreement, you have to go through the licensing and the procurement process that people go through, tons of documents that this legal team, with these legal colleagues of ours, have to go through for them to sign off on us buying the software. But as data teams, you can easily enable them with generative artificial intelligence, Gen AI, to help them go through the documents really, really fast. And these are things that we can already do. Think about how the company earns money, and some use cases where we have to do, let's say, matching across what's actually in our transactional information and what the bank sends back to us. A lot of times for our finance colleagues that actually handle this, it's more they're looking at the information manually. But then as data experts, you can already enable them with advanced analytic capabilities and simplify what they have to do. This is why this slide is very important, where data colleagues, we need to get involved beyond shipping features or shipping value to the customer to really understanding how the company makes money. But really good to see that almost everybody in here knows that the company makes money. And to really bring it into what it might look like, you might want to take a slide. The value, you can, depending on how you structure your product teams, right? You can structure around value streams or customer journeys, either way. But you can see this picture also represents diversity. This is very important for me. If you look at it from a color perspective, I didn't even know there were color tags on the table, but I just picked randomly. But this is how I think. For me, this is how I think. Your teams have to represent diversity. This is very, very important. And a lot of times people ask me, how do I remember talking to one of the leaders in my organization and said, how did you manage to structure your data platform team back then to hire as many females as possible? And I said to him or her that, see, I spoke to the recruitment team and said, I want my targets for the year is to make sure that my team has gender diversity. Send me as many CVs of the male representation as much as possible. I will not listen to you because it is my target to make sure that I fulfill gender diversity. And luckily, I have 75% females on the team at the end of the year. So as much as possible as engineering leaders, this is what we have to do. All right. And then with regards to team structure also, you can see use case 1, let's get a bit more technical, use case 2, use case N. I would say to enable with self-service internal platforms. And the reason for this is another self-made graph. I don't have numbers to it, but you can see time to value on the y-axis and the number of use cases. If you look at building everything all the way at every point in time, your time to value is very, very high. But by leveraging self-service internal platforms, you can reduce your time to value and also implement as many use cases, successful use cases as possible. All right. I think this is the final section on the team structure. Lots of people, how many of us have heard about data mesh? Good. How many of us are actually using data mesh? All right, excellent. I'm not a fan of data mesh, and I'm not a fan of central data lake. But what I believe in is the Conway's Law Plus, which I invented for myself, which is any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. But there are caveats, and budget, and customer and stakeholder expectations are not industry trends. This is very, very important. Because once you start thinking, oh, we need to put data mesh in place, we need to put this type of central data lake in place, you have to think about what is the budget, what are the customer expectations, and how we shouldn't focus on only industry trends. This is very, very important. So if you're either way, any architectural decision you want to make, think in terms of this line. And then let's switch gears a bit into ways of working. How many of us actually have clearly written out and defined ways of working for our teams? Okay. Recommendation before we go into the slides, please do. All right. So for us, and when I was leading data teams, the first thing we did was, how many of us have seen the movie Moneyball? Ah, great. I don't need to explain so much anymore. Please read the book. It's a really good one, even if the first 5 chapters, or first 2 chapters. And for us, it was about defining what data science meant. And maybe for technology teams or for product teams, you need to define what it means for us to build. And when I spoke to the data team, I said, data science for us is not about building models. It's about identifying variables and metrics that might is in blue, it's in highlighted, that might be better predictors of business performance, not just performance, but business performance. The reason for this is that I'm trying to get their focus on what works for the business. And we are here to serve the customers through the business. And it's about identifying variables, identifying metrics that might be better predictors of performance. And with that, I then help along with the team to define the strategy, which is defining the strategy as a flywheel. And a lot of us are familiar with the term, might be familiar with the term flywheel. And for us, it's very important to think, for me, it's very important to think in terms of flywheel, and we try to do this a lot at the company I work. And it first is about understanding the user and customer behavior. This is very simple. Most people assume that, oh, we are data scientists, we need to build models. No, it's about helping the business to understand the user behavior and customer behavior, and then measuring product progress, proving if product ideas work or not, informing product decisions. These are sound very basic that data science teams or data teams should be doing, but if it's not clearly spelled out, and this slide is a summary. This has a 2 or 3 page narrative behind this. That's when I said earlier that this is actually a workshop. This is the workshop. In the workshop, we actually go through the narrative, and everybody reads the narrative to understand. And finally, maybe inspiring product work. But then you can see everything links together. And at the center of it is that the data teams are unlocking internal insights and customer value. they have to understand is we as data leaders, we have to understand that we're not here just to build models or use generative AI. It has to be hinged on internal insights and customer value. We have to enable our colleagues to have a better understanding of data and how it relates to the business. And we have to use it to deliver value to the customer. And then, again, the first part has a 3-page slide. This other one, I wanted to include it, has another about 3-page slide, a 3-page narrative to it. And with this, we define how we work and how we execute as a team. We're a cross-functional data science team. And we collaborate with product teams to solve top priority. Not everything we have to do, but we solve top priority strategic initiatives with data and advanced analytics. Number one, because a lot of data teams have, or data science teams or engineering teams have a lot of PhDs in there, sometimes we tend to assume, oh, it's about research. No, we're not a research team. We are responsible for business outcomes, directly or indirectly. We engage in research. We can deploy research techniques to deliver analytic outputs iteratively. This is very, very important. And analytic outputs might be dashboards, charts, whatever it is, narratives, that we're making sure that we're delivering this iteratively on a weekly or bi-weekly basis, depending on the cadence that you work with. We value shared analytic outputs over comprehensive documentation. These are things that were adjusted from the Agile Manifesto based on my experience working with data teams, and we respond to change over following a plan. So it's not like, oh yeah, we want to build this model and then this is the way we go. No, we respond to change over following a plan. Still on diving deep on the ways of working, this is now tactics, right? So we understand the philosophical, the strategic organization, but how do we execute? So for me, it's important that as data teams, if you're working on something, it starts from the strategic initiative. And a lot of times we ask ourselves, where do strategic initiatives come from? If we hold all hands in our company, if we have all hands talks or things where the executives come to talk about the progress of the company, this is where we start from. We don't have to go across the moon and come back to figure out what is important for the company, right? These are things that company leaders talk about in the all hands. So it starts from a strategic initiative, which is related to either customers or stakeholders. And in engaging with the stakeholders, the data science team or the data teams, they're helping the stakeholders to figure out what decisions they want to make. And then we go from the decisions into the predictive questions and business hypotheses. And I will show an example of business hypothesis. We then do data work, but at the center of that is the customer or the stakeholder. This is very, very important. And then we go into modeling, evaluation, and we go into analytic outputs, which in some cases can be storytelling, it can be dashboards, it can be narratives. And then you see the deployment, which is the machine learning model. It's grayed out. There's a reason why it's grayed out. For us, it's important to understand as data people that not all data initiatives lead to some model deployment. But it's about the customer value. And if it has to lead it to a model deployment, then we deploy a model. But not everything leads to model deployment. And then how dual track, I'm sure a lot of us are familiar with the concept from Jeff Patton, which is dual track development. It's about iterating, tables, charts, reports, predictions. Iterate as fast as possible. Ship intermediate output, even failed experiments, right, are valuable outputs because we learn from them. And the learning is not only for the team, it's also for the business colleagues or other parts of the business or even our product colleagues. Prototype experiments over implementing tasks. And this is a mind shift that I had to support my team to go through. It helped, for us, it was to get the people to move away from thinking in terms of implementing tasks, but getting them into ownership. And in ownership means that we need to prototype experiments. And also getting meta, not just diving deep into details, but being able to describe the process, not only the end state. And then finally, is to climb up and down the data value pyramid as we work. So it's about getting as high level as possible and getting as detailed as possible. Because the reason for this is that this work that we do, we need to share it with our colleagues that don't speak the data language. And how do we do discovery? And for me, it's, the starting point for that is hypothesis-driven development. So how do we do that, right? Typical example is we believe that this capability, this experiment that we want to conduct, will result in a particular outcome. And then how do we measure? We will know we have succeeded when we see a measurable signal over a short period. And I'll give you a very, very recent example. So one of my teams was working on a matching use case. So we're using, how many data people are here in the, So we're using vector representations, right? It's called embeddings. So it means that if I take my name, Lekan, as an example, and I want to convert it into a number so that a machine learning algorithm can understand it. So I can take my name, and then I get the mathematical representation, which comes across as a matrix or something like that. And we wanted to use that to match it with something else. And I asked the engineers, how do we go about this? First thing was to define an hypothesis, which is we believe that representing my name or my address or whatever it is, or some random string in vector representation will result in us being able to do XYZ effectively. We will know if when we have succeeded, if we are able to have an accuracy of a certain percentage over a 7-month period of data processing. It was you can see it's very easy for everybody to understand. Even if I'm talking to a colleague in finance or let's say product, I can easily explain to them that this is the experiment we ran, this is the result. Do we accept or nullify the hypothesis, yes or no? If we decide not to accept the hypothesis, what do we do? And then a lot of us in engineering are familiar with user stories. But I will then go into what it means to accept an hypothesis and how it ties into the dual development track. So this is what it looks like. We want to run a series of experiments. That's the discovery lane. In the delivery lane is when we ship. And what we do is we define the experiment, like I explained earlier. If we accept the hypothesis and we run the experiment and we realize that we can accept it because it gives us it's within the acceptable range, then it goes into the hypothesis, into the discovery lane, and we deliver shippable data product incrementally. If it doesn't result in if we cannot accept the hypothesis, it's very simple. We reject it, we take the learnings, and then define a new hypothesis, which is we started by saying, oh yeah, in the example I gave earlier, we defined an hypothesis to use a certain technology from AWS, Amazon Web Services. It failed, and then we failed the experiment and we parked it. We tested the experiment in, I think, about 2 or 3 days. We ran a simple experiment. We defined the hypothesis. We didn't see a measurable signal that indicated that we succeeded, and then we parked it. And then went into what other hypotheses can we test. We went in a different direction, and we moved into delivering a shippable data product as quickly as possible. This is very simple. This is very easy. If you don't take anything away at all from what I've said so far, this is the most important, this is the most pragmatic thing that you can do from tomorrow, from Wednesday, Thursday, and going forward, which is agile discovery and delivery, combining both. Have a discovery lane and have a delivery lane. And then measure. You have to measure your learning velocity. How many experiments are we running as quickly as possible? How fast are we getting customer feedback? What's the time for us to accept or reject an hypothesis? These are things that we can easily measure. And then in the delivery lane, you measure delivery velocity, you can measure predictability, you can measure the quality of your shippable data products. And quality is not just, oh yeah, the predictions are in 90%. You can also measure security. How secure are the machine learning models that we're putting in production? Or how secure are the data products that we're shipping? In closing, so organize along and beyond customer value delivery. So that's why if you remember the picture earlier where there's customer stuff and then how we get money into the bank. Eliminate undifferentiated heavy lifting. Leverage as much as possible internal platforms and build internal platforms. If you want to talk about how to build internal platforms, I'm happy to share at the office hours, but build internal platforms. Also scale the platform team with the Conway's Law, which is organized based on your communication, but think about budget, think about customer and stakeholder views, not only industry trends. Define clear ways of working that can be understood by everyone in the group. This is very, very important. In fact, one of the things that I also did is, let me ask this, right? How many of us have our roles in our organizations clearly written out for us? If you have your role clearly written out for you, good. We can do a lot better. So as engineering leaders, right, the best way we can help our teams to grow and to help everybody understand the role they play is to clearly outline what their functions are. And this is very, very important. I write a lot, and this is one of the first things I do when I take over new teams is to clearly outline this is the role, this is the expectation for the individuals. Now that you understand the expectations, where are the gaps? It's not just because you want to outline it for the data people or you want to outline it for the teams. It's because it helps you to understand where is this person in their journey to meeting up the expectations, and how can I, as a leader, coach them and support them into fulfilling those expectations. Again, embrace agility with the dual track discovery and delivery. And if it doesn't work, refine, iterate. Thank you.